Sterilization versus pasteurization. Thermal processing covers a broad area of food preservation technology in which heat treatments are used to inactivate microorganisms to accomplish either commercial sterilization or pasteurization. Sterilization processes are used with canning to preserve the safety and wholesomeness of ready-to-eat foods over long terms of extended storage at normal room temperature, non-refrigerated without additives or preservatives. And pasteurization processes are used to extend the refrigerated storage life of fresh foods. Although both processes make use of heat treatments for the purpose of inactivating microorganisms, they differ widely with respect to the classification or type of microorganisms targeted, and thus the range of temperatures that must be used and the type of equipment systems capable of achieving such temperatures. Section I. Pasteurization. Pasteurization is a relatively mild heat treatment given to foods with the purpose of destroying selected vegetative microbial species, especially the pathogens, and inactivating the enzymes. Because the process does not eliminate all the vegetative microbial population and almost none of the spore formers, pasteurized foods must be contained and stored under conditions of refrigeration with chemical additives or modified atmosphere packaging, which minimize microbial growth. Depending on the type of product, the shelf life of pasteurized foods could range from several days milk to several months fruit juices. Because only mild heat treatment is involved, the sensory characteristics and nutritive value of the food are minimally affected. The severity of the heat treatment and the length of storage depend on the nature of the product, pH conditions, the resistance of the target microorganism or enzyme, the sensitivity of the product, and the method of heating. Most pasteurization operations involving liquids, milk products, beer, fruit juices, liquid egg, etc. are carried out in continuous heat exchangers. The product temperature is quickly raised to the pasteurization levels in the first heat exchanger, held for the required length of time in the holding tube, and quickly cooled in a second heat exchanger. For viscous fluids, a swept surface heat exchanger is often used to promote faster heat transfer and to prevent surface fouling problems. In-package pasteurization is similar to conventional thermal processing of foods, except that it is carried out at lower temperatures. The thermal processing of high-acid foods, natural or acidified, is also sometimes termed pasteurization to indicate that relatively milder heat treatment is involved, generally carried out at boiling water temperatures. Section I. Sterilization. Sterilization implies the destruction of all viable microorganisms and is not the appropriate word to be used for thermal processing of foods, because these foods are far from being sterile in the medical sense of the word. The success of thermal processing does not lie in destroying all viable microorganisms, but in the fact that together with the nature of the food pH, environment, vacuum, hermetic packaging, and storage temperature, the given heat process prevents the growth of microorganisms of spoilage and public health concern. In essence, it presents a thermal process in which foods are exposed to a high enough temperature for a sufficiently long time to render them commercially sterile. The process takes into account the heat resistance of the spore formers in addition to their growth sensitivity to oxygen, pH, and temperature. The presence of vacuum in cans prevent the growth of most aerobic microorganisms, and if the storage temperature is kept below 25 degrees centigrade, the heat-resistant thermopiles pose little or no problem. From the public health perspective, the most important microorganism in low-acid pH greater than 4.5 foods is Clostridium botulinum, the heat-resistant, spore-forming, anaerobic pathogen that, if it survives processing, can potentially grow and produce the deadly botulism toxin in foods. Because C. botulinum and most spore formers do not grow at pH less than 4.5 acid and medium acid foods, the thermal processing criterion for these foods is the destruction of heat-resistant yeasts and molds, vegetative microorganism, or enzymes. Because spore formers generally have high heat resistance, The low-acid foods that support their growth are processed at elevated temperature 115 to 125 degrees centigrade, whereas acid foods need only to be brought to 89 VOC for adequate inactivation of enzymes for destruction of vegetative cells, yeasts, and molds.